So here I want to do partial fraction decomposition on this fraction here. Now we've got it here 3z minus 1 over 2z minus 9 and z minus 7 squared. So we've got a repeated factor here. So my building blocks to get the answer for this one will give me some constant a over the first one, which is 2z minus 9. Then I need another factor of z minus 7. So I need to build up the powers here. This is what I need to do. Then the next one will be z minus 7 squared and some other constant. Now notice z minus 7 squared is a quadratic. But as we're building the powers, we don't need to put a linear term in the numerator. We just leave that as a constant c. Okay, so now what I'm going to do is I'm going to multiply both sides by this denominator and then get just 3z minus 1 on its own. So let's take care of that. So put a big bracket round everybody and then multiply with these factors here. 2z minus 9 and z minus 7 squared. So this expression will just leave 3z minus 1. So I've got 3z minus 1. Multiply this expression here, 2z minus 9 by this, I'll just be left with z minus 7 squared. So I'm left with a z minus 7 squared. The b z minus 7, I'll be left with one of these. So one of these and this one. So that's b 2z minus 9 and z minus 7. And then that one will cancel. And then z minus 7 squared will cancel all of that one and just leave me with 2z minus 9 plus c 2z minus 9. Okay, right. Now what I'm going to do now is to FOIL out all of these brackets. So z minus 7 squared multiplied by a. So let's go with that. So I'll have a times z squared minus 14z plus 49. This b1 here will be b times 2z squared, and then I'm going to have minus 9z minus 14z, so that's minus 23z, and minus 9 times minus 7 is plus 63, and then I'm going to have just c 2z, oh that c looks like a bracket, 2z minus 9. Okay. Right, and that's equal to 3z minus 1. So now the technique I'm looking for here is corresponding coefficients. So there is no z squared term here, so I can just write here 0z squared. So my corresponding coefficient for the z squareds will be 0. So let's set that up first. So now that will equal z squared, so I'll have an a and a 2b. So I've got 2z squared times b. So that's 2b. So that will equal the coefficient here. So I'll just write 0z squared. Now let's set up the z. So plus z. So here I've got a and minus 14. So that's minus 14a. Here I've got minus 23z and a b. So minus 23b. The z term in here is 2c, so plus 2c. And then let's just write that one in there. And then my corresponding coefficient for my constant minus 1, I'm going to have 49a. So plus, let's write this here, 49a. B times 63 plus 63b. And minus 9c. So let's just squeeze that in there. Okay, so we can see what's going on there. I'm just going to leave it like that for now. So now we've got some corresponding coefficients. So I've got a plus 2b should equal 0. I've got minus 14a minus 23b plus 2c will equal 3. And then these ones here will equal minus 1. So I've got 49a plus 63b minus 9c equals minus 1. Okay, right. So I've now got a plus 2b equals 0. So I need to do something with that and then maybe substitute into one of these. So I'm going to set a equals minus 2b. And then substitute for a, put minus 2b in here. So as a is minus 2b, I've got minus 14 times minus 2b. So now I'm going to have 28b. So with this equation here, now becomes 28b minus 23b plus 2c equals 3. And same in here, I've got 49a. A is minus 2b, so now I've got minus 98b. So this one becomes minus 98b plus 63b minus 9c equals minus 1. Okay, so we can see what's going on here now. I've got two equations here now, two variables, two equations, so they're simultaneous equations. Hopefully I can solve. So let's draw a line under all of these equations for now. So let's bring this one across simplified. 28b minus 23b gives me 5b. So that looks a lot more easy to handle. Plus 2c equals 3. And let's see if we can do something here. Minus 98b plus 63b. Well, that's going to leave me with minus 35b. So minus 35b minus 9c equals minus 1. Okay, right. Well, if I multiply this by 7, I'll get a 35 for my b. So that'd be something I can work with. So that'd be equation 1, that'd be equation 2. So equation 1 times it by 7. So I'll now have 35b plus 14c equals 21. So let's just put a little dotted line under that to show that it's separate. And now I've got minus 35b and 35b, so I can now add these together. That way then I'll get my b to disappear and hopefully I can solve for c. So that will disappear. Minus 9c plus 14c will give me 5c. Minus 21 plus 21 will give me 20. So therefore c will equal 4. So that's my first coefficient. Now as I know c is 4, I can plug that into one of these equations and hopefully get my b. So let's pull this one out. So 5b plus 2c equals 3. c equals 4. So I've got 5b plus 2 times 4 equals 3. 5b plus 8 equals 3. So therefore 5b equals minus 5. So therefore b equals minus 1. So there's another coefficient I've got. Well, if b equals minus 1, I can plug that into this one here if I like. So a equals minus 2b. b is minus 1. So a equals minus 2 times minus 1. So therefore a equals 2. So plug that into my building blocks. A equals 2. That's taking care of that. B is minus 1. So I'll put a 1 there, change the sign. And C equals positive 4. Change that C to a 4. And that is my partial fraction decomposition of this expression here. Okay.